Relating the rate equation to possible mechanisms in reactions. You need to be able to identify the rate limiting steps using information given in a rate equation. For example, if your rate equation equals rate equals K, concentration of A to the order 1, concentration of B to the order 2, this tells you that you need 1 mole of A and 2 moles of B in or leading up to the rate limiting step. If we have a look at a possible mechanism, we've got step 1 is A plus B makes AB. Step 2, AB plus a further B makes AB2. And step 3, AB2 plus B makes AB3, which is the rate limiting step, or RLS. So in this case, if I just took step 1, I've only used 1 mole of A and 1 mole of B, so that can't be the slowest step, so that's not the rate limiting step. If I look at step 1 and then go on to step 2, the AB I formed in step 2 reacts with a further B, so I'll need to have 2 moles of B and 1 mole of A to get to the product AB2 in step 2. So step 2 is classed as the rate limiting step because you've used 1 mole of A and 2 moles of B in producing the products in step 2. So step 2 would be the slowest reaction. Step 3 then has AB2 plus a further molecule of B to make AB3. This will be a fast step. You will find that in step 1 there is only 1 of A and 1 of B, so it's not that step. In step 2 you would need 1 mole of A and 2 moles of B. This is if you look in detail. If you look at step 1 and step 2, you can cancel through to show that you need 1 mole of A and 2 moles of B, so that is definitely the slow step. Step 3 required 1 mole of A and 3 moles of B, so that doesn't match the rate equation, so is not the rate limiting step. The key is to look at the overall orders of each one in the rate equation, and then the steps in turn. Given a second example, we've got rate equals K, a concentration of M to the power 2, concentration of N to the power 1. You will need to have 2 moles of M and 1 mole of N in or before the rate limiting step. Let's look at possible mechanistic steps. So the first one, M plus M makes M2, M2 plus Z makes M2Z, M2Z plus N makes M2ZM. The rate limiting step is step 3 because it's not until you get to the end of step 3 that you've used 1 mole of N and 2 moles of M. So therefore you need 2 moles of N and 1 mole of N to have the reaction in step 3. You often find a catalyst is in the rate equation, and you can tell that this is a catalyst because it appears in the rate equation but doesn't appear in the overall balanced equation or stoichiometry equation. So you quite often find they'll ask you to identify a catalyst by this means.